Now for the graphing proportional relationships section of the test. The graph below shows the time and distance for a car trip that Sarah took this summer. John also took a trip this summer, and the equation y equals 65x shows the total miles y traveled in x hours. So notice this is two separate trips going on here, John's and Sarah's. So we've got to figure out which statement is true. Is Sarah's car traveling at a faster speed than John's car? So we need to look for both of the rates of change. Remember, when you have an equation in this format, the number in front of your independent variable, or your x, is your rate of change. So that means that for every mile John travels, for every hour, because that's our x value, he travels 65 miles. So the number of miles increases by 65 every single time an hour goes up. So his rate of change, which in this case represents his speed, is 65 miles per hour. So 65 is in front of the x. Now let's try to figure out Sarah's rate of change. I'm going to look at this point right here on the graph and that point right there on the graph, because I can tell that they really easily hit a corner. So remember that when you're looking on a graph, your rate of change, otherwise known as your slope, is you change, oops, that's not what I meant to do. Sorry about that, guys. It's your change in your y values over your change in your x values. Let me recolor these in now where they make sense. So, in Sarah's case, so right here, this point is at 0, 0. This point is at 6, 300. So if I go up from that point to that point, it went up 300. Then it went over from 0 to 6, so it went over 6. So my y values changed by 300. My change in my x values increased by 6. 300 divided by 6 is 50 miles per hour. So Sarah's car is traveling at a faster speed than John's? Nope, because he's going 65 miles an hour. She's going 50 miles an hour. So we can rule out A. John's car is traveling at a faster speed than Sarah's. I'd say this is probably it, but let's rule out the others just to make sure. John's car and Sarah's car are traveling at the same speed. No, because he's going 65. She's going 50. John's car and Sarah's car are not traveling at a constant speed. Okay, that's not true either. They are traveling at a constant speed. John is always going 65 miles an hour, so he has a constant rate of change. Sarah, because this is demonstrated by a linear function, that means it's in a straight line, that means she is also driving at a constant rate of change. And you can see that because if this goes from here to up here, it went up from 300 to 500. This went up by 200. And then from 6 to 10 is going up by 4. 200 divided by 4 also simplifies to 50 miles per hour. So she is going the same rate of change constantly. You can tell that because it's a linear function. So therefore, they're both going at constant speed. That means we're right. The answer has to be B. Number 8, this graph shows the amount of weight Lucy lost over a 5-week period. What does the slope of the graph represent? Remember, the slope is the rate of change. So when you figure out your rate of change, I'm just going to pick these 2 points right here. So to go downward, so I went down 20, down to 0. So my change along my y-axis was a 20. I went over from 0 to 5. So my rate of change, so my change along my x values is 20 over 5. It's 20 pounds for every 5 weeks. So what does that help me represent? So it says, what does the slope represent? Just the number of weeks? No, because it means the number of pounds lost per week. So that's not it. Weeks per pound loss? No, that's backwards. If it were weeks per pound, weeks would be on top, pounds would be on the bottom. Remember that your y value, your dependent variable, goes on the top when you're talking about your slope. So you can't do that either. Maximum number of pounds lost, it doesn't tell us. It just tells us the rate that she's losing it. Pounds lost per week, and that's what it is. 20 pounds per 5 weeks. So our answer is C. After takeoff, an airplane climbs at a steady rate. So that's our clue. We're looking for a rate of change. The illustration below shows the rate at which the airplane climbs. What is the rate of change for the line that represents the airplane's height? Remember, rate of change is your change in your y value, your change over your x value. We also call that rise over run. So let's look and see how much it's rising. So it's rising 1,000. Oops. Gotta stop clicking this little button on my pen. Sorry, guys. And then it goes across. My run is 1,500. So therefore, my rate of change is A, 1,000 over 1,500.